Okay, so this is what I want to do. So this is just number 6 on this worksheet. So I have -9 and 11. So what this problem is asking me to do is that I'm going to have to derive a, let's do this here. There you go. Put up here, deriving a parallel equation. So the first problem that I'm going to do, we're going to derive a parallel equation. So, and how this works is that you're given an ordered pair, and then you're provided an equation that you have to make a parallel one to. Now, this is done in some steps. So we'll do it this way. So step 1 is that you're going to have to rewrite original equation to isolate for y. So we have to rewrite 5x minus 10y equals 3. We have to rewrite that so that way we can isolate it and have y by itself. Now, why are we doing that? Why do you think we have to isolate this equation for y? Why do you think? Yes. Yes, we want it in y-intercept form. What were you saying? Y is a dependent. Yes, we definitely want to have it in function form, slope equals mx plus b, y equals mx plus b. So that way we can have y be the dependent variable. But we need this for another major factor outside of that. Why else do we want to have this in slope-intercept form? We will, but we have to figure out something before we plug the coordinate in. Why else do we want this in slope-intercept form? Parallel equations have the same what? So what do we have to find? The slope. We're doing this so we can find the slope. So I want to put down here, I want to put 2, find the slope. We have to find the slope. If we don't find it, then we can't do anything. So now we have to rewrite this in order to find the slope. So now I have 5x minus 10y equals 3. Now, all of you at your table, go ahead and isolate this equation for y. And I'm going to ask somebody in here to walk me through the entire process in about another 2 minutes. So rewrite this entire equation and isolate for y. Because we've got to find the slope in order to find a parallel equation. Somebody ready to walk me through it, or I'm just going to call somebody at random? Okay, I'm going to call somebody at random then. So we're going to do that one. Let's go with Bethany. Talk to me. Where's Bethany at? Okay, walk me through it. What am I doing to isolate for y here? I'm going to subtract 5x from both sides. So 5x minus 5x minus 10y equals 3 minus 5x. Okay, that looks really nasty. Oh, hold on, I'm sorry. Okay, so now I have a negative 10y equals 3 minus 5x. Okay, now what? I divide negative 10 into everything individually. And this is why now that it has a negative, you really want to make sure you do it this way. Because the sign is going to change the values of everything it's being divided into. Because negative also means opposite. This is where you want to divide everything individually by negative 10. So now, Bethany, what else? Talk to me. Y equals negative 3 over 10. Look at those signs closely. Plus, not quite 2. There you go, 1/2 x. If you didn't get the 1/2, she just divided 5 into 5 and 5 into 10. But now this is not in slope-intercept form, right? So what should it be in slope-intercept form? Perfect, yes. This is your original equation here. Put a box around that. You can even put next to it, you can put OG if you need to. This is your original equation. We need to find one that's parallel to this that goes to that ordered pair that we wrote earlier up on this illustration here. But now that was step one, right? So now step two, I think I'll just keep going down here. So now step two means that we have to indicate the slope. So now indicate the slope for step two. What's the slope of this equation here? All of you, what's the slope of this equation? So, what is it again? All of you real loud, what is it? 1/2. So m equals 1/2. Put a box around that. We now have our slope. So first we had to rewrite the equation for y just to get our slope. Now we have our slope. Now we have our step 3, which I'm going to say is going to be use y equals mx plus b to derive a parallel, using notation, equation. So now we're going to use the y equals mx plus b form to do this. All right, this is how it works. Let's put the formula there. Y equals mx plus b. An ordered pair was given to us. Can somebody tell me what the ordered pair was? -9 and what? And 11? That's what I wrote down at the very top? Okay, sorry. Didn't realize I did that. All right, yeah. So, ordered pair given to us. And now we also have our slope. What's the slope of this problem here? What's the slope that we have from the step 2? All right, so 1/2. All we do now is plug in that ordered pair and that slope into this y equals mx plus b to start finding our new equation. Because now we're going to find a parallel equation. We have the parallel slope, which is 1/2, and we have the ordered pair supposed to go through. I'm going to put x here, y here, because that's the ordered pair. Now let's just plug everything in. I have 11 equals 1/2 times -9 plus b. Now the rest of you go ahead and figure this out. Find your b, and then give me that parallel equation. So find your b, and then write the parallel equation. You might have a decimal, but I mean, you should be fine. What's 1/2 of 9? 4.5. What's 11 plus 4.5? All right, so now we have our b. Arvin, can you provide me our new parallel equation now? So our parallel equation, what is that? No. We have all the pieces we need now. Now I just want my equation. I got all the pieces I need now. What you got? Perfect. That's our new equation now. This is the parallel equation. We had the original one, which was y equals 1/2 x minus 3 over 10. We know parallel equations have to have the same slope. We indicated that. We used our same slope, 1/2. Then we had to use the ordered pair provided, -9 of 11. We did that, and now we have our new equation. So this is how to derive a parallel equation. This is what you have now on the top of page 60. What is it, 82? 82. Now let's do perpendicular equation.